This video explains the development methodology of the Python-based urban heat island dashboard for Pulau Pinang. The first step was importing the required Python libraries. Streamlit was used to build a dashboard interface, Rasterio was used to read raster dataset, NumPy and Pandas were used for data processing, Folium was used to produce the interactive map, and Plotly was used to generate interactive charts. Next, the dashboard page was configured using Streamlit. A wide layout was selected to provide sufficient for maps, indicator and charts. Custom CSS was also added to create a dark glass style interface with organized containers. The raster and CSV file path were defined using the Python path library. All required files were stored in the same folder as the Python program. The raster processing function reads each TIFF file using Rasterio and convert the raster into a numerical array. No data and valid pixel value are removed to prevent incorrect statistical results. The function then calculates the mean, maximum, minimum and total number of valid pixels for each dataset. A maximum sample of 10,000 valid pixels was selected for the charts. Sampling reduced the amount of data processed by Plotly. The land use land cover information was loaded from a CSV file using Pandas. This dataset contains the area of each land cover class for 2021 and 2026. Interactive controls were added to the sidebar. User can select either 2021 or 2026 and choose between the LST and UHI dataset. They can also adjust the raster opacity and change the base map style to improve the visualization. A conditional statement automatically select the correct raster statistic, color scheme and unit according to the year and metric selected by the user. For example, selecting LST for 2026 loads the 2026 LST raster, while selecting UHI for 2021 loads the corresponding UHI dataset. A climate mitigation simulation was included to demonstrate the potential effect of increasing tree canopy coverage. User can select a canopy expansion percentage and the dashboard applies a simulated cooling adjustment to the mean and maximum values. This component is only a simplified simulation for demonstrating possible cooling effects and does not directly modify the original raster or represent a field-validated prediction. 4 KPI indicators were created to summarize the selected raster. These indicators display the total number of monitor pixels, mean value, maximum value and minimum value. When 2036 is selected, the dashboard also shows the difference compared with the 2021 values. Before displaying the raster on the web map, its coordinates were transformed into EPSG4326. This coordinate system uses latitude and longitude and is required for displaying the data correctly in Folium. The raster values were normalized using common minimum and maximum values for both years. This ensured that 2021 and 2026 use the same color range and can be compared more consistently. The processed raster was converted into a color image and overlaid on the volume-based map. The map allowed users to zoom, move across Pulau Pinang, adjust transparency and control the display raster layer. A group bar chart was created to compare the area of each land cover class between 2021 and 2026. The chart allows users to compare changes in urban, forest, agriculture and water body areas. The net land cover change was calculated by subtracting the 2021 area from the 2026 area. Positive value indicate expansion while negative value indicate reduction. The complete dashboard combines LST, UHI and LULC information for Pulau Pinang in one interactive platform. User can select the year and metrics, examine the raster map, view statistical indicators, compare multi-year trends, analyze land cover changes and explore a simplified tree canopy simulation. Therefore, the dashboard provides a clearer and more accessible way to communicate urban hill island result compared with static map.